Okay, so far we've factored quadratics for solving them, but that won't always work. A lot of things aren't factorable. Completing a square is another way that you can solve a quadratic. It's been around a long time, and I'll try to explain you sort of how it works, and then we'll do a couple of examples. So yesterday, or the other lesson, we talked about, well, if you have x squared equals 5, you can just take the square root and you would get x equals, and then you would have to make sure you did plus or minus the square root of 5 to make sure that you have both of the answers that you need. Okay. Well, if I wrote that, let's say I wrote x plus 2 squared equals 5, then I think I should still be able to do this. So I'm going to take the square root. So when I take the square root on this side, this square root and that square cancel. So that means that I just get x plus 2. And then on the other side I get plus or minus the square root of 5. Well, x is not by itself yet. I don't really need the brackets. So I could definitely erase the brackets. That means I could subtract 2. And then you can't subtract the 2 here, but we could pretend we had a 0. So if you do that, you end up with a negative 2 plus or minus the square root of 5. So my question to you is, well, what did we really solve over here? What did I solve over there? So let's go back and FOIL that thing out and see what we have. So x plus 2 squared. So let's see, I had x plus 2 squared. That means I had this. So x times x is x squared plus 2x twice, so that is plus 4x plus 4 equals 5. So if I brought that 5 over here, I would have the following quadratic equation. Okay, that's it. Well, you are completing the square then means that we take an equation like this and we solve it by writing it as a something in parentheses squared, and that's, well, we call that a perfect square, and the process of that is basically the opposite of what you just saw me do here. So I'm going to do it again, and now I'll complete it. So I would bring the 1 over here, and I would get x squared plus 4x is equal to 1. Well, I want this then to be x plus something squared equals 1. So what number do I need here so that when I FOIL it you get 4x? Well, keep in mind that the 4x came from 2x plus 2x, so the same thing twice. So the thing here, if you want that to be a 4, has to be a 2. But if you write x squared plus 4x as x plus 2 squared, you really wrote that as, let's see, x plus 2 squared would be x plus 2 times x plus 2. That is x squared plus 4x. That's great. And 2 times 2 is 4. So I would argue I have an extra 4 here. So I'm going to put an extra 4 over here. And that's what they call completing the square, is when you write this as a square. So now I wrote that as a square. Then you have to complete the square by balancing the equation out. So I think of it as balancing. So I end up with this, x plus 2 squared equals, and 1 plus 4 equals 5. Then I take the square root, so you end up with x plus 2 equals plus or minus the square root of 5, and then finally end up at the same answer. And then that would be called completing the square. Okay, I'm going to do this a couple more times. We'll do it now without really worrying about what it is, and I'll just show you, try to show you what the process is. So on these, you actually want the numbers to be on the right. So you want x squared plus 10x, and on this side you want it to say then equals 8. Okay, I'm going to write this side as a perfect square. So x plus, keep in mind that the number here when I use it twice, I get 10. So really what you're doing is you're just doing 10 divided by 2, and that would be 5. Then to balance this, I have to add 5 times 5 is 25. I have to add an extra 25. So that's actually the balancing, is adding the square on the other side. Okay, so I do x plus 5 squared, 8 plus 25 is 33. And then I take the square root on both sides, plus or minus the square root of 33. Subtract 5, imagine that 0 there, so it becomes a negative 5 plus or minus the square root of 33. So, solve the quadratic. Here's another example. Well, I want to write it something like this. That means I need in this case I'm going to need a y squared there, so let's divide by 2. In this case that's not a problem because all these are divisible by 2. Of course, I do have to divide all of them by 2. Okay, then write that as a square. Make sure you use a negative now because you want this to be negative 2. So half of 2 is 1. And that means to balance it, I need to add 1 squared, which is just 1. So I get y minus 1 squared equals 5 plus 1 is 6. Take the square root on both sides, plus or minus 6. Move the 1 over, and so you get, now you're doing plus 1 to balance this out, or cancel it. So that's 1 plus or minus the square root of 6. Okay? Last one. And this will sort of show you when it doesn't work real well. So I'm going to move the 1 over. And we have to make it say m squared, so I have to divide everything here by 3. So that's great there, but now I end up with fractions over here and over here. And most of us don't particularly like fractions. It still works though. You can still write this as m squared equals 1 over 3. That's a plus. So now what I need to do is I'm doing 4 over 3 divided by 2, which would be 4 over 3 times 2 is 2 over 1. So the reciprocal of that is 1 over 2. So that's 4 over 6, which would be 2 over 3. So I'm going to do plus 2 over 3 squared, and then here I need to add 2 over 3 as a square. So m plus 2 over 3 squared equals 1 over 3 plus 2 squared is 4, and then that becomes a 9. Take the square root, plus or minus the square root of, now write this as an over 9, so that becomes 3 over 9 plus 4 over 9. And then I can subtract the 2/3, so it's minus 2 over 3 plus or minus square root of 7 over 9. But you can't leave that, because that actually could be written this way. So 7 over 9 could be written, or the square root of that could be written this way, and the square root of 9 I do know. So you end up writing this as the negative 2/3 plus or minus the square root of 7, and the square root of 9 is 3. That actually is sort of a self-check there, that you probably did it right since you ended up with an over 3 twice. Okay, so this is an example of completing the square that it does work, but the fractions usually scare people off a little bit. You'll have to do a couple of those, but down the line, probably not tomorrow, but pretty soon we'll learn another way that you can solve a quadratic that won't involve fractions. Thanks.